Assalamualaikum and greetings to everyone. We are from BEI 1/2. Today we are going to present about mini project electrical magnet, Lorentz law and Fleming left hand rule. My name is AHMAD SABRI and my partner is Muhammad NURAQMAL bin Muhammad SHARIFF. First, I will introduce you about Lorentz law. Lorentz law is created by Dutch physicist Henrik Anton Lorentz, who first formulated the electric force on the charged particle is parallel to the local electric field. The magnetic force, however, is perpendicular to both the local magnetic field and the particle direction of motion. This is the formula for Lorentz law force. QE is electric force and QV multiply with B is the magnetic force. This is the face of Henrik Anton Lorentz, the creator of the Lorentz law. He is born 18 July 1853 at Arnhem, Netherlands. He died at 4 February 1928 on age 74 at Haarlem, Netherlands. Somewhere other charge and current have generated an electric field and magnetic flux density. This field exerts a force on charge Q equal to this formula. This Q is the charge, ER is the electric field, and BR is magnetic flux density. Here the force due to ER is electric field could be parallel to velocity vector. So what is the importance of the Lorentz force law? It is explain the mathematical equation along with the physical importance of force acting on the charged particle. They are traveling through the space containing electric as well as the magnetic field. This is the importance of the Lorentz force law. Next is the example of the application the Lorentz force law in real life. This show the cathode ray tube television use the concept of the Lorentz force to deviate the electrons in straight line, so land on the specific spot on the screen. This is the example of the cathode ray tube television. Next, I will show you the simulation of the Lorentz force law. Lorentz force law is about the force exerted on the charged particle moving with velocity through electric field and magnetic field. On the switch, we can see right now the yellow particle is the electron moving from negative to positive. And the red particle is the electron moving from positive to negative. When the particle is moving, it will create a little magnetic field around the wire. As you can see, the green direction is the magnetic field that around the wire. And when we flip the direction like this, the magnetic field circle will also around it follow the movement of the particle electron. This magnetic field is created by the electric from the battery. So to do the simulation, we use the offshore magnet with the north and south pole. This is north and south pole. The magnetic field in this magnet is always from the north to south pole, moving like this blue arrow direction. Okay. We also use the green wire as the pendulum. So the magnet we put like this. Let's see what happened to the electricity runs through the wire. The wire will swing forward because it creates a different of the direction magnetic field. The green is the direction of magnetic field from the electron, and this blue is the magnetic field created by the magnet. So it's the different magnetic field, so it cannot be in same space, so the wire is moving forward. When we flip the battery and also the reverse the direction, the current of the magnetic field also create the opposite direction. The cause the wire swing backwards. The direction of the magnetic field from electrons is moving backwards, so the pendulum will swing backwards because it cannot be same space with the magnetic field of the magnet. So lastly, also when we flip the magnet like this, also cause the wire or pendulum swing forward because of the magnetic field also different. As we can see, it's moving like this, so it cannot be same with the magnetic field of the magnet. So that's all of the simulation of Lorentz force law. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad NURAQMAL bin Muhammad Sharif, and today I will explain about Fleming left-hand rule. Introduction of Fleming hand rule. Fleming left-hand rule is used for electric motor. It's one of a pair of visual mnemonic, and the other being Fleming right-hand rule is used for generator. They were originated by John Ambrose Fleming in the late 19th century as a simple way of working out direction of motor in an electric motor or the direction of electric current in an electric generator. According to Fleming left-hand rules, when current flow through a conducting wire and an external magnetic field is applied across that flow, the conducting wire experiences a force perpendicular both to that field and to the direction of the current flow. In example, they are mutually perpendicular. Each finger is then assigned to a quantity which is mechanical force, magnetic field, and electric current. Okay, right now I will show you animation on how to use Fleming left-hand rule. Okay, the object shown is a motor, and can we determine in which direction will this motor rotate if direction of magnetic field and the current is given? Okay, we will discuss one rule which is Fleming left-hand rule, on the basis of which we can find the direction of force, the rotating direction of armature coil for the given direction of magnetic field and current. Okay, according to this rule, if you arrange your left hand in such a way that your thumb, first finger and second finger all point at right angle to one another, if your first finger is pointing to the direction of magnetic field, second finger is pointing toward the direction of current, then the thumb will give you the direction of the force. Okay, now let us check out the left hand rule against the animation. Okay, now let's us understand this by taking a simple circuit. Now arrange left hand with thumb, first finger and second finger all pointing at right angle to one another. Okay, now point first finger in the direction of the magnetic field point, second finger in the direction of current according to Fleming left hand rule. The thumb will give the direction of force. In this case, the conductor will experience a force in upward direction or it will move up. If you understand it, if you have understanding, now you can guess in which direction the conductor will experience a force if we reverse the direction of current. Okay, I think that's all for me.